Hare Krishna everyone, welcome to a new lecture on your electrostatic series. Okay, we will start with our electric flux and Gauss theorem today. It is a very important portion of your electrostatics. So let's start with our electric flux. What do we mean by electric flux? Okay, electric flux means the electric flux through a surface means it is defined as the total number of electric lines of force, the total number of electric lines of force passing normally through the surface. Okay, through the surface. When I am talking about the electric flux through a surface, then I will have to consider the total number of electric lines of force, okay, associated or passing through that surface normally. Mark my word, I am saying it normally, okay. You have to consider the lines of force which are normally passing, okay. So by definition, electric field strength is the number of electric lines of force passing per unit area normally, okay. So if ds is my elementary area, okay, then I can write flux as your what? E dot ds, because when I am considering the electric lines of force, then which quantity is showing it? The electric field strength E is the number of electric lines of force passing per unit area normally, okay, isn't it? Yes. Then I can write the flux phi is equal to your E dot ds. Remember that I have represent the electric flux by the symbol phi, okay. You will also have to represent this as your phi symbol, okay. So if I am taking the elementary area ds, then I will have to write here is the d phi. If I will have to find out phi, then I will have to integrate over d phi if the body is continuous. If the body is continuous, then I will have to integrate it. Otherwise, I will have to summation it, okay. So what I will get if I do this integration or summation like this, I will get, okay. If I will do the summation, then I will get like this, summation I, okay, E dot ds, isn't it? Yes. When I am taking the summation, that was for your discontinuous surface, okay. So let me show you through an diagram. If this is my surface ds, okay, and I have to draw, let's suppose these are my electric lines of force perpendicularly passing through the surface area ds, then I will have to write the flux as phi is equal to your E dot ds. If I am considering this area only as ds, then I will have to integrate it as this, okay. Did you understood? Yes. So how it will be if my electric lines of force make some angles, electric field make some angle with your surface vector, okay, the surface vector. So how it will be if I will have to write, let us, it makes a angle theta with your ds vector, okay. So I will have to write it like this, E ds, okay, E ds cos theta, okay. I will have to take the component along your perpendicular direction, okay, that is your cos theta. So let's talk about its units and dimension of electric flux. Electric flux. So in SI unit, if I will have to talk about the unit of your electric flux, it will be as my phi is equal to your E dot ds. The unit of E is your what? Newton per Coulomb, as we have known that force per charge, the Coulomb, is equal to your electric lines of electric field strength, that is E. So into your area is your meter square, so the unit will become Newton into meter square into Coulomb inverse. Okay, do you get it? Yes, make it a underline so that you could easily access it. Okay, this one is SI unit. If I will have to consider CGS unit, then you will have to write it as your dyne into centimeter square into start or half Coulomb, start Coulomb inverse. Okay, understood? Yes, you can write also the half Coulomb here. Okay. So let's talk about its dimension. If I will have to write the dimension of electric flux, what it will be? Similar. You have to first write the formula for it, that is your E dot ds. Then write the dimensional formula for your E. Dimensional formula is your force per Coulomb. Force, the dimension of force is m1 L1 T minus 2, and Coulomb is your A1 T1 into your ds, that is your meter square, means your L square. Okay, so it will become your m1 L3 T minus 3 and your A1. Okay, so this one is my dimension formula for your what? For your electric flux. M1 L3 T minus 3 A minus 1. So here A minus 1. When A is going to the numerator, you have to write it minus. Okay, so this one is the dimension formula for your what? Electric flux. And we will see a problem here. Let me write a question. Okay, easy question on this concept. For your concept clarification, I'll write a close question here. Okay, the electric field strength is given by your 6 I cap, 2 j cap, 3 k cap. Okay, and you have a surface on xy plane, and it is given as your xy plane, and it is 50 units. Okay, you have to calculate the flux associated with the surface. The surface is given in which plane? XY plane. Remember, the question is asked that the surface is on XY plane. Okay, let me write the solution for you. The surface is on XY plane means the surface vector is along which direction? Surface vector is along your z direction, means your k cap direction. Okay, isn't it? As the magnitude of surface is given, that is your 50 units, I can write the direction along with its direction. I can write the surface vector, S vector, is what? Is your 50 k cap. Okay, I know the formula for your flux is E dot ds. Here ds is how much? 50. So I will write the electric field is given by how much? That is your 6 I cap plus 2 j cap plus 3 k cap. Dot product with your what? Area vector. Area vector is how much? 50 k cap. So by dot product you get, that is k cap dot k cap will be valid, and others I cap and j cap will be equal to 0, as we are doing the dot product. So it will become your 3 k cap dot 50 k cap, which will be equal to your 150. Okay, k cap dot k cap is 1, so it is 50 into 3 is 150. Okay, so this one is your flux. Remember, electric flux is a scalar quantity. Okay, when we are talking about the electric flux, it is a scalar quantity, scalar value. Okay, So let me talk about a very important concept in physics. Okay, very important concept, that is your Gauss theorem. Okay, Gauss theorem. Okay, many important problems will be solved through your Gauss theorem. It will make your problem simplified by using Gauss theorem. So what does the Gauss theorem state us? The theorem states that the total electric flux through a closed surface, or you can say the Gaussian surface, okay, is equal to your 1 by epsilon times the total charge enclosed within the surface. Okay, let me start with the theorem. Let me write the theorem. The theorem, the Gauss theorem states that the Gauss theorem states that what does it say? That the total electric flux through a closed surface through a closed surface, or you can say it as your Gaussian surface is equal to 1 by epsilon naught times 1 by epsilon times the total charge. Remember, you have to write the total charge. Okay, you can't write the total charge. You have to consider the whole amount of charge enclosed within the body. The total charge enclosed within the surface, enclosed within within the surface. Okay, I think you got clear with my definition or language. Okay, mathematically we represented electric flux or Gauss theorem as your phi is equal to your integration over E dot ds, that is equal to your 1 by epsilon naught times the total charge. Let the total charge is capital Q into epsilon naught, and I can also write is your Q upon epsilon. Okay, this one is the mathematical representation of your Gauss theorem. So let me prove this for you. Let me prove the Gauss theorem for you. Sometimes in examination question asked that you have to prove Gauss theorem. Proof of Gauss theorem. Gauss theorem. Proof of Gauss theorem. So how can we prove it? Okay. For proving it, let me consider a surface, a closed surface, a Gaussian surface. Okay. Let me consider a Gaussian surface like this. Gaussian surface like this, and let us consider this one as my ds. This elementary surface as your ds. Here consider the point O and draw with your endpoints of ds. Okay, I have drawn it. Here you have to know the solid angle concept, because we will use this concept here. I'll talk about it. Okay, don't worry. If you don't know, don't worry. I will talk about it. This is your E vector. This is your angle theta. This is your d omega, that is a solid angle. This is your plus q charge. This is your r vector. Okay, here the direction of normal is along this direction of normal. Okay, here this point is p. Okay, this one is ds. Okay, all clear. So you have to consider few points here. Let a point charge plus q coulomb be placed at O, as I have shown here. Here a plus q charge is placed at your point O within the closed surface. Okay, let E be the electric field strength at P. At this point P, let I have the electric field strength E. Okay, let OP length is R. Okay, and the permittivity of free space or vacuum is your epsilon naught. As you know, we denote the permittivity of free space as your epsilon naught. Okay. And consider a small area ds as I have considered here. Okay. Surrounding the point P. Yes. Then the electric flux through ds vector will be given by, if I will have to write the electric flux through your ds vector, it will be your df d phi is your E dot ds. Okay. This much is clear to you or not? Okay. I hope this much is clear to you. Okay. But the electric field strength at P, I can write the electric field strength electric field strength at P point, I can write it as your E vector is equal to 1 upon 4 pi epsilon naught, as your permittivity of free space is epsilon naught, into Q upon R square and the direction R cap. I can also write it as 1 upon 4 pi epsilon naught Q upon R cube into your R vector. Okay, isn't it? Yes. So d phi will become what? D phi, I have d phi as your E dot ds, so it will become your 1 upon 4 pi epsilon naught q upon r cube r vector dot your ds vector, isn't it? Yes. As I have know that d omega, that is your solid angle, is represented by your your r dot ds upon r cube. Remember this, d omega, your solid angle, is represented by your this much quantity, okay, which is the solid angle. Let me write it for you. Solid angle subtended by area ds at the point O, as in the diagram I have shown you that, see here, the area ds subtended the solid angle d omega at the point O. That's why I write d omega as your r dot ds upon r cube. So I can write the final expression as your d phi is equal to your q upon 4 pi epsilon naught into d omega, isn't it? Yes. Give it a equation number 1. Okay. Hence, the electric flux through whole of the closed surface will become, if I will have to write the whole of the surface, then I will have to integrate, because that one is a continuous surface I have taken. So, through the surface integration, E dot ds, this will become your q upon 4 pi epsilon naught integration over d omega, isn't it? Yes. As I know your d omega, integration over d omega, the solid angle due to the entire closed surface, closed surface is, okay, at the internal point O. Okay. So what does it mean? For d omega is the solid angle subtended at the O point due to the surface ds, and when I am taking the integration over d omega, it will be the due to the surface S, isn't it? Yes. So I can write atef I can write phi as your q upon 4 pi epsilon naught into 4 pi, as for this surface, due to the whole surface, the value of this is 4 pi. So it will become your 1 upon epsilon naught. By cancelling 4 pi, you can get 1 upon epsilon naught into q, where q is the total charge enclosed within the body. Okay. So, do you get it or not? Okay. Hence, it is proved. The Gauss theorem is proved or not? Gauss theorem says what? The theorem states that the electric flux through a closed surface or Gaussian surface is equal to the 1 of 1 epsilon naught times the total charge enclosed within the body. The total charge is Q and it is multiplied by 1 of 1 epsilon naught. Hence, the Gauss theorem is proved. Okay. Sometimes in examination, the questions comes from that prove the state and prove the Gauss theorem in electrostatics. Okay. Hence, the electric flux, the total electric flux through any closed surface, surface is equally to 1 of 1 epsilon naught times the total charge in Coulomb. You can write the Coulomb enclosed within that body, enclosed within that surface. Within that surface. Within that surface. So this is all about your Gauss law. Okay. In the next lecture, I will tell you about the application part of your Gauss theorem. In this lecture, I will end with your derivation of Coulomb's law from Gauss law. A very, very important portion of this derivation of Coulomb's law. Okay, Coulomb's law from Gauss law. Remember, this one is a very, very important point. Okay, very, very important proof. Always asked in your examination. You can check that in past 5 years it may be come in 2 or 3 times. Okay, so you can. Okay, so let me start with the diagram first. In order to derive the Coulomb's law, you have to draw this diagram. Let me take a spherical surface. Okay, in space having the flux Q charge at the center, and due to this at the point phi I have electric field E vector. Let us consider a surface here, and this one is your ds vector. Okay, and let the radius of this is r. Okay, let me write it for you. Let us consider a charge plus Q is kept at the position O, position O in free space. Okay, imagine a sphere of radius r around the point O. Okay, now choose an elementary area of ds. Choose an elementary, as I have chosen in the above figure, elementary area ds at any point p, okay, of the sphere. Okay, so what did I do? I choose a plus q charge in free space at point O. I have considered a sphere of radius r around point O, and now I have choose the elementary area ds at the point P of the sphere. Okay, so the electric lines of force, I am writing it as ELF. You have to write it as electric lines of force. Okay, emitted is normal to the area. You have to consider it. Okay, normal to the area. You have considered that the electric lines of force emitted are normal to the area. Okay. Now the electric flux. Now if I write the electric flux associated with the closed surface, that is phi E will be equal to your how much? Integration over E dot ds, isn't it? Yes. So it will become your S integration over S E ds cos 0 as your area vector and electric lines of force are parallel. So the angle between them is 0 degree. So it will become EDS, that is your maximum value of electric flux. Or I can write it as phi E is equal to your integration over EDS. If I write the area, so it will become E into 4 pi r square. Let me take question number 1. Okay. So from Gauss law, what I know, that is phi E, I can write phi E as your 1 upon epsilon naught multiplied by Q, isn't it? Let me take question number 2. By comparing both the equations, that is equation number 1 and equation number 2, I get your E into 4 pi r square is equal to your 1 upon epsilon naught into Q, isn't it? I can write E from here as your 1 upon 4 pi epsilon naught into Q upon r square, isn't it? See, I have just arranged it. Okay. E is equal to your 1 upon epsilon 4 pi epsilon naught into Q upon r square. Okay. If a test charge, let me take equation. Okay. Let me take equation number 3. If a test charge or unit charge, you can say test charge Q naught is kept at the point P, okay, then it will experience force. It will experience a force given by your F is equal to Q naught E, that is F is equal to your Q naught multiplied by 1 upon 4 pi epsilon naught into Q upon r square. So it will become your 1 upon 4 pi epsilon naught Q naught upon r square, isn't it? So you got the Coulombic force for me from here. What I have written in your first heading, that is the derivation of your Coulomb's law from Gauss law. Isn't it the Coulomb's law? What Coulomb's law says us? It says the Coulombic force. It says about the Coulombic force. So this one is the Coulombic force expression from your Gauss law. Okay. This is, I can write, this is nothing but your Coulomb's law from Gauss law. Okay, isn't it? Yes, I have derived the Coulomb's law in electrostatics from Gauss law. Very simple, very simple. Okay, very simple derivation. What you have to do is, you know that your electric flux is given by your E dot ds integration. Okay, you write that, and after that you know the Gauss law. Gauss law is 1 upon epsilon naught into Q. Simply compare both the equations. Okay, you can get E from here, and for finding out the Coulombic force, you have to take in the test charge at the point P, and now as you know F is equal to your Q naught of into E, so you can write the expression F as your 1 upon 4 pi epsilon naught into Q naught upon r square, isn't it? Yes, this is all about today's class. So if you like the video, do subscribe to my channel. It will give me enormous motivation to proceed further. Okay, thank you very much for watching the lecture. Thank you from my heart. Okay, thank you everyone. If you have any doubts, then you can post it in comment box. I will definitely look upon it. Okay, thank you for your kindly response.